Learning about intermediate value theorem. Characteristics of a function on a closed continuous interval. Somewhere on the interval there will be a maximum and a minimum. Right? So here we have some functions on closed intervals, and every one of them has a maximum and a minimum. Right? So there we have a maximum, and by the way, I'm looking for global max and mins in this particular case, right? So there is a maximum, and then right here would be our minimum, and here would be our maximum, and here's the minimum, and I would say these two are probably equal. And here's, oops, a minimum. And then a maximum and a minimum. All right, so we're going to be looking at things like, we're going to be looking at specifically continuous closed continuous intervals, right? And using intermediate value theorem to learn some things about continuous closed intervals. So when discussing maximum minimum, there's a difference between absolute maximum and relative maximum. And so, by the way, global and absolute mean the same thing. Right? So same thing. So here we do a little demonstration of global and absolute and relative. So think of dropping a ball. The starting point is absolute maximum. The starting point and each bounce are relative maximums. Right? So the bounce is going to be the highest thing in an area, and then the starting point is an absolute max or global max. It's the highest value of all for a particular function here. You might notice the play button, so probably more impressive live. However, I'm going to hit the little play button, and then you can see the play button hitting, and there goes our ball. It's bouncing. So it hits the ground and bounce, and back on the ground, bounce, and back up and turns around. So notice each bounce is isn't going as high anymore. It's losing its bounce. And so forth, and then it pretty much just stops bouncing and it's just sitting there on the floor. All right, so this would be a global or absolute max. And each of these bounces, when it bounces and then it goes back up again, right? These are all relative max. Right, so there's one there, and there, and there, and so forth. So intermediate value theorem. Right, we'll come back. We'll be talking more about global absolute maximums in a very soon to be later lesson. But right now we're going to look at intermediate value theorem. So intermediate value theorem for continuity. F of x, because it'll all go together. If f of x is continuous on the interval a, b, and k is between f of a and f of b, right? So k, of course, is a y value, because f of a and f of b are y values. Right? So that's y. That's x and x. Right? So notice the brackets, it's closed interval here. And this would be a y value, and that would be a y value. Right? So if f of x is continuous on an interval a, b, and k is some y value, and it's between f of a and f of b, then there exists a value c between a and b such that f of c equals k. So let's look at a little example here. Right, so there has to be at least one x value that satisfies intermediate value theorem, but there could be more. Right, so here is, we're looking for right here, that's k. Right, and so up here Right? That is f of a. Right? And then over here is f of b. Right? So there's f of b. Right? So it's along this line here. I'm going to erase that just because b is right there. Right? So here's a, and here's b. Right? So those are x values, and of course f of a and f of b are y values. Right? So as I'm going between f of a and f of b, which is technically, actually I should move it over here. So it's showing you across the line there, but technically it's right there. Right? There's f of, oops, well, can't move that over anymore. There's f of a and there's f of b. Right? So here our function, it leaves f of a, and there, it crosses, it crosses again, it crosses one more time. So there are actually 3 places for this particular example. 3 different c values. So we have c1, c2, and c3. 3 different c values where f of c equals k. And what if that wasn't our function? What if our function looked more like this? What if it was linear? Even if it was linear, there's no way to get from f of a to f of b, right, without crossing that line k, right? I can't hop over it, or I won't be continuous anymore, right? So there's no way to go from, by the way, you follow along in your notes. And when you see me writing something in your notes, and you write that down too. There is no way to go from f of a to f of b without crossing the line y equals k. Right? Just can't do it, no matter what it looks like. But there's, and my little arrow is going to move now. So it's going to point to where we're reading. There's no guarantees that there's a c such that f of c equals k if the function is not continuous on the interval, right? Because I could start here, and then I'm stopping, and I'll pick up over here, and look at that. Oh, I missed k altogether. Here's k. Poor k, he was missed, all right? Right, so if the interval is not continuous, right, that function isn't continuous on that interval, then intermediate value theorem, you can't be used at all, right? Can't use it at all. Has to be only for continuous functions, and I should say functions that are continuous on an interval. Right? They don't have to be continuous everywhere, so long as they're continuous on the interval. All right, here's another example here. If we have a, hey, I don't have my little arrow here. Here it is. Here to point the way. If we have a continuous interval on a and b, and a value k is in between f of a and f of b, there must be a value c such that f of c equals k, at least one. Right? So here, my function is continuous on a and b. Right? So the function has to go through every y value between a and b. Right? And so here's k. Right? I cannot get from here to here without crossing that line, right? Here I go. I'm trying not, I got to cross it. I can't get there, right? So you've got to cross that line somewhere. There has to be at least one. Sometimes there's more, but there's got to be at least one value of x. So this is an x value. One value of x such that, and it would be right here. Make the dot nice and big. Right here, f of c equals k. Right? Right there's the spot. Right? If your function's continuous, right, you have to have at least one x value for every single y value. Right? So can you use intermediate value theorem to find the zeros of our function? Right? So, I meant to erase this. Should pretend it's not there. Forget it's there. All right, now I can talk about it. All right, so can we use intermediate value theorem to find the zeros of the function? Our function is and we're told that our function is continuous on the interval. Right? I'm going to put given is given that our function is continuous on the interval -2, 5. Right? So if we're looking for zeros, right, that means that k equals 0. Right? That's our y value. Our y value is 0 right there. Right? And so we're continuous, right? So there's not going to be any breaks. Right? So we're starting off here at -2, and I'll write in blue. And I have a little graph here just to help us out. And I probably should move my words and maybe not write in blue because I don't know where my words are going to go. So I'm probably just going to write right through them. All right, so we start off at -2, -2, 6. Hey, I wanted purple. That's not purple. Let's see if this is purple. All right, and so now we're going to go to -1, 2. There we go. Excuse me, -1, -2. And we forgot the 6 to negative over here. All right, so we're at -2, -6. We're going from -1, -2. All right, so haven't crossed it yet. All right, and then we go to 0, 3, which is right here. And notice somehow, somewhere, right, but to get from here to here, I have to cross that value, the k value there. I have to cross k equals 0 or y equals 0. Right? It's not possible for me to go from negative to positive without crossing the x-axis. Right? So it's k here is 0. It's also our x-axis. So right here, there has to be a 0 because there is a sign change. We went from negative to positive. So every time there's a sign change and you have a closed continuous function, you'll know that there has to be a 0 somewhere between those two x values. Now, I just made up where it goes. I don't really know that it goes there. It could go someplace else. You know, maybe it's over here, right? And it goes like this. Right? I don't know where it goes, right? But I do know that there's no way to go from negative to positive without crossing the x-axis. Right? So intermediate value theorem won't tell us where the x-intercepts are. They'll just tell us that there are x-intercepts. Right? So IVT doesn't tell us, and this would be good to put in your notes, hint, 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 doesn't tell us where zeros are located. Just that they exist between two x values anytime y changes signs. And so the y coordinate, or just put y changes signs. All right, so let's see if we can find any more. All right, so now we go from 1 to 5. All right, so that's up here. All right, so no more zeros so far. All right, then we go from 2, then we go to 2, -1. All right, so now I got to cross it somewhere. I don't know that it's here, right, but it's somewhere. Right, so at our x's, we crossed somewhere between the two x's. Right, the one where it was positive, and the one where it was negative, or the one where it was negative, and the one where it was positive. Right, so we crossed between here, between -1, 2, and 0, 3. We also cross between when x is 0 and x is 2. Right, so there's another 0. Right, so right here, got to be a 0. Right, because this time we went from positive to negative. Right, and then 3, -4, which is down in my words here somewhere. Right there. Right, not a 0 there. Right, we haven't changed signs. And then 4, -2, not a 0 here, because we haven't changed signs. All right, but then notice we go all the way up here, to 5, 2. So somewhere there has to be an x-intercept on that interval, right? So every time we change signs, there's going to be an x-intercept between those two x values. So right here again, we've got a 0. Right? And so that's how you can use intermediate value theorem to find zeros, or define that the zeros exist. It's actually an existence theorem for finding zeros. So it's existence theorem for finding zeros. Doesn't tell us where they are, just tells them, well, kind of, I mean, it tells us it's in between two x values, but it doesn't tell us exactly what x value, but we do know what two values it's between. Anytime we change signs, we go from positive to negative or negative to positive. Right? So let's look at some more things with intermediate value theorem and finding zeros. All right, so characteristics of a function on a closed interval. Intermediate value theorem, if f of x is a closed continuous interval on a, b, then f of x takes on every value between a and b, and this comes in handy when looking for zeros. Important, intermediate value theorem is a theorem that can be used as a justification on the AP exam. For a closed continuous interval on a and b, where a value k exists between f of a and f of b, so you've got some y value between two other y values. According to intermediate value theorem, there must exist at least one x value. So this is an x, this is an x, this is an x, this is a y, this is a y, this is a y. Right? Between a and b, such that, oops, f of c, what did I do? Let me get back to the way it was. I must have hit the little extended page. I didn't think I got that close. This was an x. And such that f of c, right, so that would be x equals k, equals that y value. Right? Very, very important though. You must show the function is continuous on a closed interval. Sometimes it's given to you, and it might be as simple as saying that we're given that. Oops, there goes my pen. Right? So if it's given, just like a geometry proof, then state it is given that whatever the function is continuous. Right? You must state that. Right? You can't just say, well, it's up in the answer, right up in the answer there. They should know that's a continuous interval. They want to know you know it's a continuous interval, and they want to know that you know that it's important that it's a continuous interval, and that you can only use intermediate value theorem if this is a continuous interval. Right? So if it's given, then state it is given that f of x is a closed continuous interval. If it's not, you'll have to show it. Chances are it's given, and you just have to state it. Make sure you state it. All right? People have lost points last year because they didn't state it, even though it was right in the question. You got it. You got to state it. It's your given. Right? You got to use those givens. Right? So maybe you guys won't forget. All right, so let's look at this one. Can we use intermediate value theorem to find the zeros of the function? So anytime the sign of f of x changes from positive to negative, right, or negative to positive, we must cross the x-axis. The function is continuous. By the way, when I put the c or the x over here, I was pointing to the c. I probably should have said that. So the c here is the x, right? F of c, of course, would be a y. All right, so let's take a look here. All right, so negative 3, 4, positive, and we'll look at the y values, negative 2, 1, positive, up, negative 1, negative 1, negative. All right, there's got to be a 0 here. I should have wrote it like this on the other page. Negative 1 there, up, we got positive. All right, so got to be a 0 again. All right, and then we're positive, positive, up, negative, right, negative 2 there. All right, so there's got to be a 0 here. And then look at that, negative 2, positive 2, right, it's got to be another 0 here. So every time there's a change in the sign of the y value, right, we have to, we'll know that there has to be an x-intercept, a 0, right, between those two x values. We don't know exactly where between the two x values, we just know it's between the two x values. Okay. I like the way I put the pluses and negatives there. I'm going to do it on this one as well. So right here, instead of writing positive to negative, I'm just going to, it'll be less busy and everything, and I think easier to follow. All right, so I'm just going to do it one more time for this one. Real quick, lickety split. All right, so negative, negative, positive. Got to be a 0. Positive, negative. Got to be a 0. And negative, negative, positive's got to be a 0. So we had them all listed, but I think this is easier to follow. All right? So anytime the y value changes signs, right, it's a continuous function. Intermediate value theorem is stating that, states that on a closed continuous interval, right, that every y value has to be represented between the two endpoints of that interval. Right? Can't skip anybody because you're continuous. And that's where I'm going to end this podcast. And I have some for you where you're going to tell me where the 0 is. Right? And so there's it's multiple choice. Right? I'll have a graph and it says A, B, C, D, E, I think. And you tell me which of those points there is a 0. All right? Thanks for watching. Bye for now.